Hello everyone, I am Dr. Shraddha Sahu, Assistant Professor Biotechnology from Faculty of Engineering and Technology, Rama University, Kanpur. We will discuss today enzyme inhibition and the enzyme kinetics. So coming to the topic, what is enzyme kinetics? Actually there were some scientists who told us about the how the rate of the biochemical reaction can be defined. So what is the rate of the biochemical reaction? The rate of a biochemical reaction means the pace of the reaction or the speed of the reaction, and how we will measure the rate of the biochemical reaction is a question. So how we will measure? So we can only do two things. First, in the enzymatic reaction, as we all know, that the substrates are getting converted into products. So how the substrates are getting converted into products? The substrate and enzyme interacts and forms a substrate enzyme substrate complex, which is an intermediate or the transition state. And finally, due to this interaction, some biochemical reactions and the bond, some breaking up of the chemical bonds takes place, and thus the substrates are getting converted into products. So these either we can observe the disappearance, we can observe the disappearance of substrate or the appearance of or the formation of product. Both things can be measured with respect to time. So the change with respect to time here will be the conversion of substrate into product. So there were two scientists. This is the Michaelis-Menten plot. This is called as the Michaelis-Menten plot, where we can, with the help of this plot, we can understand how the rate of biochemical reaction can be measured. So simply, if we want to measure the speed of something, we can say what is the velocity. So here we can measure the velocity of the reaction, biochemical reaction, and with respect to the substrate concentration. So here we can observe with respect to time how much substrate are getting converted, disappearing, and we will record the velocity. So the substrate concentration will be measured in terms of millimolar concentration of substrate we will take, and V naught represents the initial velocity of the reaction. So we can measure it micromole per minute. It means how much micromole of substrates are getting converted into product per minute of time. This will be the rate of biochemical reaction. So as we can see here, that with respect to time, the substrate concentration here, the substrate concentration, and here the reaction velocity. V naught is the reaction velocity. So the substrate is getting converted into products. As the substrate is going on decreasing and the substrate is getting converted into product, the rate of the reaction is increasing with the increasing concentration of substrate. We can say here, with the increasing concentration of substrate, the rate of the reaction is increasing in a very logistic way, and after a certain extent it reaches up to its maximum, and then it becomes stationary or stable. So here if we are measuring V naught or initial velocity, reaction velocity in the y axis, so we can see here the V naught reaches to its maximum value. So this is the maximum V naught, V max. This point will be called as the V max, and this V naught we can define. So here we can say this is the point where the V max has reached. This is the point where the V max is at its half. So half of the V max on the y axis, and to the corresponding on the x axis we take corresponding value of the substrate concentration. So the corresponding value of the substrate concentration where the V max reaches at its half, this will be called as the Km. So the Km value of the enzyme. So this is all about the Michaelis-Menten plot. What happens since there is a stationary phase or the stable phase, beyond this the rate of the reaction is stable, and while increasing the substrate concentration, now all the enzymes, we can say all the enzymes active site are saturated with the substrate. So, there is no effect of increasing the substrate concentration beyond a certain limit. So, the V max is stable. So, because of this, proper calculation was not possible. This was the drawback of Michaelis-Menten plot. So, another scientist came and they told about the Lineweaver-Burke plot. This is also called double reciprocal plot. So, because of not finding the actual value here, what we are doing? We are getting the actual values by taking the reciprocal of all these parameters. So, we are taking the initial velocity, reciprocal of initial velocity here in the y axis 1 by V naught, and the reciprocal of substrate concentration here 1 by substrate concentration. So, by getting this Km, this will be the minus 1 by Km. So, this will be and 1 by V max. So, the slope of the graph will be Km on V max. So, by the help of this Lineweaver-Burke plot, we are able to deduce the actual values. So, this is the normal enzyme substrate reaction, or the reaction of the normal functioning of the enzyme when the rate of the biochemical reaction is measured. So, now we will discuss about the enzyme inhibition. What is enzyme inhibition? Enzyme inhibition is the phenomena or the point where sometimes it happens like the enzyme, in place of binding with the substrate, it binds with the inhibitors, certain inhibitors which inhibits the activity of enzyme, or which captures, traps the or stops the activity of the enzyme. So, there are some inhibitors, like, do we call or can we say that always the enzyme inhibition is harmful? No, it is not harmful, because we can see in many, we can say in our day-to-day life, the herbicides, most of the herbicides, pesticides, and most of the drugs which inhibits the cell wall of bacteria, they are the enzyme inhibitors. So, we have so many drugs which have the mechanism of stopping a particular kind of enzyme, so that we can solve a particular purpose. So, there are three types of enzyme inhibition: competitive inhibition, non-competitive inhibition, and uncompetitive inhibition. So, what is the speciality of a competitive inhibitor? The speciality of competitive inhibitor is that firstly is resembles with the substrate, with its it has a structural resemblance with the substrate, and it competes with the substrate for active site. So, here it binds to the free energy. Suppose this is the free enzyme, though competitive inhibitors binds only with the free enzyme, and it instead of forming the enzyme substrate complex, what it forms? It forms the enzyme inhibitor complex, due to which the product formation is inhibited. In this way, the competitive inhibitor binds, and this can be called a kind of reversible inhibition. Reversible inhibition. Why this competitive inhibition is reversible? The reason is that since there is a structural resemblance, so when we increase the concentration of substrate in the mixture, this inhibition is stopped. So, the concentration of substrate increases, and the substrate will occupy all the active site of the enzyme, available active site of the enzyme, and due to the less concentration of inhibitors, the substrate will be able to bind to the active site, and this reaction will be possible. So, in this way we can overcome the competitive inhibition by increasing the substrate concentration. So, if we look about the look into the Lineweaver-Burke plot, what happens in the case of competitive inhibition is, since see this is the no inhibitor presence, and this is the normal reaction, normal enzymatic reaction. On increasing the inhibitor, on increasing the inhibitor, the competitive inhibition increases, while on increasing the substrate concentration, the competitive inhibition can be overcome. So, here what happens? Here the V naught, which is the initial reaction velocity, it decreases. How it decreases? Because initially there is a competition between the substrate and inhibitor. So, therefore, the initial reaction velocity it decreases, and which can be overcome, and because it can be overcome by increasing the substrate concentration, so there will be no effect on the Vmax. So, Vmax can still be achieved after the competitive inhibition has occurred. So, that is why, and the Km value will be increased. Here the Km value will be increased in case of the competitive inhibition. Now, coming to the non-competitive inhibition, what happens here? Here there is no structural resemblance between the inhibitor and the substrate. Rather, the structure of substrate and inhibitors are totally different. So, therefore, the inhibitor binds to a different site other than the active site. So, there is no need of binding an inhibitor to the active site of an enzyme. So, when there are two possibilities, either the inhibitor binds to the free enzyme and forms the enzyme inhibitor complex, and the substrate is left apart, and due to this the enzyme substrate inhibitor complex is formed. Okay. And the another possibility is when the substrate has already bind to the active site of this enzyme, what happens? It again, this inhibitor can bind to this ES complex. This is the formation of ES complex has occurred, already happened. After that, the inhibitor binds and the ESI complex. So, because of the formation of ESI complex, this product will not be formed, there will be no interaction between the, no possible interaction, and this what happens, this changes the shape of the enzyme, due to which the interaction, the maximum interaction between the substrate and the enzyme is impossible. Because of this it cannot be overcome by increasing the substrate concentration. So, in this case also V naught decreases, and V naught decreases because initially the reaction is hampered because of the coming of the inhibitor, and the Vmax also decreases because while we are increasing the substrate concentration as we were doing in the competitive inhibition, by increasing the substrate concentration there is no effect on the inhibitor. So, in this way Vmax is decreased and the Km remains same in this condition. So, a very good example of competitive non-competitive inhibition is the cyanide, which inhibits the enzyme cytochrome oxidase. And in the case of competitive inhibition, a very good example was a drug named antabuse. What happens if some person is alcoholic? So, alcoholic person have an addiction towards the alcohol. So, in those individuals what happens, the alcohol metabolism, in the process of alcohol metabolism, one enzyme comes, this alcohol oxidase. What this enzyme does, alcohol aldehyde oxidase, this alcohol oxidase, what it does, sorry, this is not aldehyde oxidase, this is alcohol oxidase. So, this alcohol oxidase catalyzes the conversion of alcohol into the acetaldehyde, and due to the accumulation of acetaldehyde in the alcoholic person, what happens, there is the symptoms like nausea and vomiting. So, if you go to the doctor, if such individuals go to the doctor, and the doctor will recommend antabuse, which is a drug, and this drug will inhibit this enzyme. it will act as an inhibitor for alcohol oxidase, and due to this the acetaldehyde formation will not happen, and the person will be getting relief from the nausea and vomiting. And now the next type of enzyme inhibition is the uncompetitive inhibition. In this uncompetitive inhibition, what happens? The enzyme, the inhibitor, it has no structural resemblance with the substrate, and so it is not competing with the substrate, it is again not competing with the. So, this is one thing I forgot to tell you, this non-competitive inhibition is a irreversible inhibition, and what uncompetitive inhibition, like here also the structural resemblance, there is no structural resemblance. So, what happens? There is another site in the enzyme where this inhibitor is going and bind, but it is not binding with the free enzyme, it only binds with the enzyme substrate complex. So, this if binds to the enzyme substrate complex, enzyme inhibitor substrate inhibitor complex is formed, and due to the formation of this complex the product is not formed, and thus this uncompetitive inhibitor acts. So, here is a question, can this inhibition be overcome if we increase the substrate concentration? No. Increasing the substrate concentration favors the inhibition, uncompetitive inhibition. Okay. So, here also increasing the substrate concentration will not help in achieving the Vmax. So, therefore, the Vmax is decreased, the initial velocity is decreased, and the Km is also decreased in this case. So, this is the graph for Lindweber plot graph for the uncompetitive inhibition. So, talking about the uncompetitive inhibitors, examples of uncompetitive inhibitors, there are many drugs which are used as uncompetitive inhibitors to treat the cases of poisoning by methanol and ethylene glycol. And one another example is the tetramethylene sulfoxide, this also acts as an uncompetitive inhibition. So, all the inhibitors are not bad, we can say all the inhibitors, sometimes the inhibitors as per the applications what we are doing to use, sometimes these are helpful and beneficial, and sometimes we need not to have enzyme inhibition. So, that is all for today's class. Thanks.